All right, if you're an electrical professional in Victoria, you know that switchboard safety is absolutely everything. But here's the thing, the real challenge isn't just knowing the standards, it's about understanding how inspectors actually interpret them when they're standing on your site. So today, we're going to break down those crucial clearance and access rules that can literally make or break your compliance.
And this is exactly where projects get into trouble. A design can look absolutely perfect on paper, but if it fails in practice, well, it fails completely. These subtle little breaches, they lead to seriously costly rework, and, way more importantly, they create massive safety hazards. Okay, so let's kick things off with the absolute foundation, the minimum clearance rules.
First things first, we got to talk about the baseline. These are the foundational rules that every single installation in Victoria has to follow. And believe me, they are the very first thing an inspector is going to check with their tape measure.
The number you have to burn into your brain is 1 meter. Simple as that. For any commercial or industrial switchboard, there has to be 1 full meter of clear, totally unobstructed space right in front of all accessible faces. And look, this isn't just some random number. It's the minimum space you need to work safely, to get away from a potential arc flash, and to allow for a rescue if the absolute worst happens.
Now, like with any rule, there is one key exception. For a single domestic installation, this front clearance can be dropped down to 0.6 meters or 600 mils. But the distinction here is critical. This only applies to those standalone domestic setups, not big multi-residential buildings or any kind of commercial site.
So you see, it all comes down to knowing your environment. 1 meter for commercial, 0.6 for domestic. But what's really interesting is what the inspectors check next. They'll actually swing the switchboard doors fully open, or they'll rack out equipment as far as it can go. Even then, there must still be at least 0.6 meters of clear space left. And trust me, that door swing, it catches so many people out.
And you know, this whole idea of clear space leads us perfectly into our next topic, the life or death matter of emergency egress. When you're dealing with high-energy switchboards, an arcing fault can unleash an incredible amount of force in an instant. A clear, guaranteed escape path isn't just a nice-to-have, it's absolutely non-negotiable.
So what's the first thing that kicks these stricter rules into gear? It's all about the board's rating. 800 amps is a pretty common threshold in the industry, and it's where an arc fault becomes significantly more dangerous. Once you hit this level, you're officially playing in high-energy territory, and the rules for getting out of there get much, much tougher.
The second trigger, well, it's just about sheer physical size. A switchboard that's over 3 meters long creates a pretty unique physical risk. Think about it. During a fault, the board itself could become this massive burning barrier, literally blocking the only way to safety for someone working on it.
So if you answered yes to either of those questions, the 800 amps or the 3 meters, then these 3 things become mandatory. No excuses. You need 2 separate emergency exit paths, and they need to be spaced well apart. The doors to that room have to open outwards in the direction you'd be running. And crucially, those doors cannot be lockable from the inside. You have to be able to get out in a panic, every time.
Okay, but there is one very specific exception. You can get away with a single exit, but only if you provide a massive 3 meters of clear, unobstructed space in front of the entire length of the switchboard. And this has to be a permanent, guaranteed clearance zone, enough room for someone to get around a serious hazard at the board.
And this brings us to what is, for me, the most frustrating part of compliance. It's where perfectly good designs completely fall apart in the real world. These are the common traps that inspectors find day in and day out on Victorian work sites.
Look, that mandatory clearance zone we've been talking about, it's sacred, but it's constantly under threat from other trades putting in their HVAC ducts or cable trays. We also see permanent things like storage shelves being built right into that space, or even temporary construction materials just left there, just for now. For an inspector, any obstruction, permanent or not, is a fail, period.
To really see how this plays out, let's walk through a super common Victorian scenario. Now let's see how a compliant drawing can still fail on site. This is going to show you just how easily a project goes from compliant to non-compliant right in the middle of construction. So picture this. There's a new commercial plant room. The electricians, they've done their homework. The drawings are immaculate. The switchboard location is specified perfectly, right down to the millimeter, all according to the rules.
In fact, the drawings show a front clearance of 1100 millimeters. That's 1.1 meters. That's fantastic. It's more than the 1 meter minimum, so it gives everyone a nice, comfortable safety margin. At this point, on paper, this project is 100% compliant.
But then, well, you know what happens next. The site coordination just breaks down. Plumbers and mechanical contractors come in to run their services, and they are not looking at the electrical clearance requirements. Nope, they're just looking for the fastest, most direct path from point A to point B.
And this is the result. By the time the electrical inspector shows up for the sign-off, new pipework has been installed smack bang in front of the switchboard, cutting the actual clearance down to just 700 millimeters. That generous 1.1 meter space? Gone. The installation is now non-compliant, it's unsafe, and it's going to need expensive rework.
So, the big question is, how do we avoid this disaster scenario? Well, the key is being proactive with on-site verification. Let's build a quick, simple checklist to make sure your installations are compliant not just on paper, but in the real world.
Okay, let's run through it. First, get your tape measure out on site. Physically confirm that 1 meter minimum. For the big boards, walk the 2 egress paths yourself. Test the doors, make sure they open out and aren't locked. Always, always account for that door swing. But honestly, the most important steps are the proactive ones. Talk to the other trades before they start their work and physically protect that clearance zone with barriers or clear markings during construction.
And you know, that really just boils it all down, doesn't it? The standards might use some general language like sufficient space, but the real-world interpretation by Victorian inspectors is strict and it's absolute. They are looking for a permanent, fully unobstructed zone that's designed for real-world scenarios, from doing routine maintenance to a worst-case emergency.
Ultimately, it all comes down to this one question. Because in Victoria, the only thing that matters when an inspector walks on site is the reality of what's been built. Thinking practically isn't just good practice, it's the only way you're going to ensure compliance and safety right from day one.